All right. Hey guys. So, in this video, let's review together then the descending tract, and that would be our pyramidal tract or the corticospinal tract. So instead of starting at the spinal cord like we did last time, we're going to start instead at the cerebral cortex, which has the motor area. And as we all know, the motor area is in the frontal lobe, anterior to your central sulcus, in what we call pre-central gyrus. Okay, so the pyramidal cells are located here, and so this what we would call upper motor neuron. The upper motor neurons are going to send down their axons, and the axons, as you remember, are going to be squeezed between the thalamus on one side and the globus pallidus and the putamen on the other side. Now this is the internal capsule. As it's descending down, it's going to bypass the midbrain, and in the midbrain it's going to descend in, if you remember, a structure that we discussed together. It's a little bit exaggerated. A structure that is here and there that we called the cerebral peduncles. Okay, so these fibers that are descending, let me just erase a little bit here, and because they're going to be descending on the same side of the cerebral cortex, and that will be in this region here. Again, we call that region the cerebral peduncles. And now they will continue descending down. They will pass the pons and then ending in the medulla oblongata. And so at the medulla oblongata, 85% of the fibers are going to cross to the other side, leaving behind only 15% of these fibers. Sounds good? So 85% of the descending pyramidal tract is going to cross to the opposite side. Good. Then as it's descending down from the medulla oblongata, it's going to go down to the spinal cord. In the spinal cord, this is the error we went over at the lecture. At the spinal cord, let's take a segment here of the spinal cord. We agreed that it is going to occupy the lateral region. So it's going to be descending in this area. That is your lateral corticospinal tract. These are the fibers that already made it. These are the ones that crossed to the other side. It's going to keep going down through the segments of the spinal cord. So let's say that this was a cervical segment, and then it's going to go down. Let's say that this particular nerve is an intercostal nerve. So you're going to go to the thoracic region, and the nerve will start exiting. So over here, we're going to have a motor nerve. So let's see how we get from here to the motor fibers. So again, the axons are descending down, and they crossed. 85% have crossed at the medulla oblongata, and they will continue in front. There is a bulge on the medulla oblongata. We call that the pyramid. And then they will continue in the spinal cord in the lateral corticospinal tract. Now, as they continue going down, at the level of the spinal nerve, at the level of the motor nerve exiting the spinal cord, they will relay the message to the lower motor neuron. So the lower motor neuron now is going to take the message forward to the muscle. So the cell body of it is here, and that will take to the corresponding muscles. Sounds good? So this is what we call the lateral corticospinal tract. What about the anterior one? Well, and the anterior one is the one that did not cross. So that's the 15%. 15% will continue going down. That means they will have to cross later on. And they will cross in this region. This is again the mistake that we had in the lecture. In the anterior corticospinal tract. And now continuing going down, at the level of the spinal nerve, they're gonna cross to the other side and feed the motor cells in the ventral horn. That is your pyramidal tract. So, in summary, we have the pyramidal cells, that's the upper motor neuron. This here is the lower motor neuron, which are your cells in the ventral horn. Now, the upper motor neurons are going to send the axons. The axons are descending at the level of the medulla oblongata. 85% will cross to the other side. That means decussate. 15% will continue going straight forward. The ones that decussated will be on the lateral corticospinal tract. The one that will continue moving straight down, these are your anterior corticospinal tract. These ones will also decussate at the level of the spinal cord. Therefore, all the fibers have decussated. Sounds good? So this is our corticospinal tract. The corticobulbar, which is the other direct motor tract, is kind of the same, except that it doesn't go to the spine. It's going to end just here in the brainstem, depending on which cranial nerve it is. If it's 3, 4, that would be the midbrain, and then 5, 6, 7, and 8, that would be your pons, and then from below that will be your medulla oblongata. So there is no spine, there is no ventral cells, or ventral motor cells. So the lower motor neuron cells will be at what we call the nucleus of the nerve. So if it's the trigeminal nerve, will be at the nucleus of the trigeminal nerve. If it's the third oculomotor nerve, it will be in the nucleus of the oculomotor nerve. What's interesting about the corticobulbar tract is that all the, let's draw it together here. Let's just stay here. So the cortex, nothing is changing at the cortex level. So the fibers that are descending now are just gonna go to your brainstem. And so let's take the pons, and let's take cranial nerve number 7. So here is the pons, and we have cranial nerve number 7, facial nerve, has facial nerve nucleus here, facial nerve nucleus over here. This is the motor nucleus. And so these guys, which are going down, we have actually 2 nuclei for the facial nerve. That's an exception to the rule. One of the nuclei will control the upper face, and the other one here will control the lower face. Well, perhaps I should have mentioned the abducens, or the oculomotor, to begin with, not this one, as it's more complicated, but nevertheless. So this one here, it's supposed only to feed the contralateral side, supposedly. So this one will feed the contralateral upper motor, right? So it's going to feed this one, and it's going to feed the contralateral lower face. Sounds good? Except when it comes to the facial nerve, then this one will also feed the ipsilateral, but not both of them. It will only feed the ipsilateral upper face nucleus. Sounds good? So, where is our upper motor neuron? Right here, in the cerebral cortex. Where is the lower motor neuron? Right here and there, in the pons. These guys are in control of the upper face. These guys are in control of the lower face. What does that mean? Then these fibers from both nuclei are going to form to you the facial nerve. So the facial nerve is coming like that. Okay? The upper will feed the upper, and the lower will feed the lower. So this guy will feed the eye, and this one will feed to the mouth. Yeah, that's the mouth, more or less. So, fine, we'll make it red for you. So now it's a mouth. Okay, here is a nose. Okay, so again, your upper face, as you can see, will be innervated by two neurons. The ones that are coming, because exactly the same thing happening on the opposite side. So this guy, the upper face nucleus, is receiving information to contract the muscle from both sides of the brain. As you can see here, this side gave this and that. That also means that this side of the cerebral cortex is also going to give this and that, right? So the upper face is bilaterally innervated, right? Whereas the lower face is only unilaterally innervated. That's why if someone gets a stroke here, or a stroke that destroys this bundle, then you're not expected to see an upper face paralysis. Instead, you will see a lower face paralysis. Whereas in Bell's palsy, which is a lower motor neuron paralysis, damage that happens here in the lower motor neuron, then you expect both to exist. Sounds good? So the difference here is that in the facial nerve, the upper part of your face, is controlled by nuclei, facial nerve nuclei on both sides, but both of them, or each of them, is innervated independently by both sides of your cerebral cortex. Understood? So this is what we had in our lecture, and that was just an example of the corticobulbar tract. We don't have to learn more of the details of the tracts as we have learned with corticospinal tract, but we just need to appreciate the fact that cranial nerves number 3, 4, and 6, they work together, and also 5, the mandibular branch of the trigeminal nerve, that will be independent. So, but it's unilateral. Those guys have to work together because anything that moves the eyes have to be coordinated together. This guy here is your trigeminal, and that will be, will be bilaterally represented. This guy is bilaterally represented. That means upper motor neuron damage in the trigeminal area, or the area that feeds the trigeminal nerve, is not going to result in paralysis of your mastication muscles. And then we go down the road. 6 is over here, 7 is the facial, 8 is sensory, and then we go to the glossopharyngeal and the vagus accessory, and finally the hypoglossal. What's interesting about the hypoglossal, it's a unilaterally represented. That means the hypoglossal nerve, unlike the upper face, so it will pretty much resemble the lower face, the hypoglossal. We don't have to remember those things for the exam per se, but it's kind of an interesting for you to understand that if someone is coming with, let's say, facial nerve paralysis, and if the person is displaying paralysis of the muscles of both the upper and the lower face, that means the damage is not in the cerebral cortex. The damage is in the nerve itself. The person did not get a stroke in the cerebral cortex. He may have got a damage in the nerve, or in this nucleus, which is rare to have a damage there in the pons. So whereas if the person comes to you having a damage on both upper and lower, then you expect the person, like I said, to have a lower motor neuron. But if he's okay with the upper, but not okay with the lower, that is upper motor neuron paralysis, right? So he has got a stroke of some sort, so he can blink his eyes, he can close this eye, but this side of the mouth would be paralyzed. Okay? All right, so this concludes our direct pathways. We started with the corticospinal, then we went to the corticobulbar. We talked about interesting examples of the corticobulbar. We did talk about specifically the facial nerve, because it's very common to see someone with facial nerve paralysis. There is a foundation out there for Bell's palsy, and a lot of people are posting their videos and support groups, so it's not something that is rare. It's actually very common to have Bell's palsy, but you have to remember that the Bell's palsy is a lower motor neuron paralysis. How do we know the difference? Because it affects both the upper face and the lower face. If it was only upper motor neuron paralysis, then it will affect only the lower face and not the upper face. Sounds good? So this was the review for the descending direct tracts, and that hopefully takes the confusion and the mistake that was made in the lecture about what is anterior tract and that what is lateral tract, the corticospinal tract. And so hopefully this review and the previous review I made earlier on and I posted to you will hopefully allow you to wrap up this important chapter in anticipation for the exam that we're having next week. Have a great day.